All right, in our next piece here, we're going to focus on infinite limits. So take a look at this picture for yourself. And we're going to focus on a few things here. First, you just go ahead and sketch it in your notebook. And then we're going to talk about the limit as x approaches 0 from the left of f of x. And we'll also talk about the limit as x approaches 0 from the right of f of x. Okay, so here's 0, correct? The word approach means to get closer to. So if I start on the left end, because it says from the left, and I follow the graph towards 0, I'm approaching 0, I'm getting closer to 0, closer, 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 but I got to follow the curve. Where is that curve headed? We would say the limit from the left is equal to infinity. That curve is going up forever. If I come in now from the right, so the limit as x approaches 0 from the right side of f of x. So now I got to come in from the right. So I'm going to start at like 12. And I'm going to approach, I'm going to get close, I'm going to go towards 0 from the right-hand side. Where is that function taking me? You got it, back up to infinity. So I can say that the overall limit, the limit from the left equals the limit from the right. I'm going to say the limit as x approaches 0 of f of x is infinity. Okay, my left side's going to infinity, my right side's going to infinity. And again, the definition of a limit is the left has to equal the right. They are the same, so I would say it's going towards infinity. Take a look at the second example here. Okay, let's talk about the limit from the left and right again. So the limit, and just jot that in your notebook, as x approaches 0 from the left of f of x. And we'll talk about the limit as x approaches 0 from the right of f of x. And then we'll just talk about the limit in general, the limit as x approaches 0. Okay, so there's always three things we want to talk about. The limit from the left, the limit from the right, and then the actual overall general limit. So again, that word approach just means get close to. So I'm going to start on the left based off this symbol here. So the left of 0, I'm on the left side here, 0, I'm on the left side of it. And I'm going to approach. I'm going to go towards my 0, going towards the 0, and look where it's taking me, down towards negative infinity. Now I'm going to approach 0 from the right side because of this plus sign. And again, approach means get close to it. I'm going to go towards 0, but this time it's taking me towards positive infinity. Does the limit from the left equal the limit from the right? Hopefully you're saying no. Therefore, the overall general limit does not exist. And a DNE is perfect notation, does not exist. It's universal. Everybody should know DNE stands for doesn't exist. You don't need to write it out. So again, for a limit to exist, the limit from the left has to equal the limit from the right. And we've got our definition of a limit existing. So let's take a look at just a sort of AP type multiple choice question. Which of the graphs agree with this statement? So the question says, the limit as x approaches 1 is infinity. So here's what's got to run through your head. Did they say left, right, or do they want both for the general limit? Well, since it doesn't say left and right, the general limit means you need to check both. So let's look at option A. I want to approach 1 from the left side. So here's 1, right? If I follow the graph from the left side's going to positive infinity. The right side is going towards negative infinity. So right away, the limit does not exist. The left side did not equal the right side. Let's take a look at the next example. So here's 1. I'm going to go just slightly to the left of it because it's a little goofy. So I'm going to start at 0. If I go towards the left, it's going up to infinity. If I come in from the right and approach 1, it's going up to infinity. Notice how I just said the same answer, infinity, infinity. I would say this limit is approaching infinity. And let's look at choice C. As I approach the left, looks like it's going to negative infinity. On the right, positive. So again, I would say that overall limit does not exist. My two answers were not the same. So I'm only going to go with choice B here. I'm going to switch over to decimals for a minute, and I want to talk about a few functions. So hopefully this shows up on yours as well. All right, so obviously I have nothing graphed at the moment, and I'm going to go ahead and graph this function I have pre-typed in here. 2 over x minus 1. So I think you can start to see there is a vertical asymptote taking place. Okay. Can you see the vertical asymptote? Can you see where when they go to positive infinity or negative infinity or in each direction, they're creating this vertical asymptote? And I think, I'm going to go ahead and say, I think it's right around maybe this value here. So I'm going to go ahead and graph x equals 1 as well. What do you think? And I can try to zoom in and out here. As I approach 1 from the left, you can see this is going towards negative infinity. As I approach 1 from the right, it's going towards positive infinity. So overall, let's just make a note to ourselves. The limit does not exist, but what it did create is a vertical asymptote. Okay, so I just throwing this out here. I want you to look at this function, this 2 over x minus 1. And I want you to take note that the vertical asymptote was at x equals 1. Okay, and just think about that. Do you see any correlation? Do you see where that maybe could have come from? All right, let's take a look at another function. I'm going to turn these off. And I'm going to graph this crazy function. 3x over x squared minus 5 plus 3. All right, and how many vertical asymptotes do you think could be taking place? Okay, and it's really when those answers go to positive and negative infinity, my hands are going all over here, that's when you see these asymptotes. So I would say there's actually, it looks like to me like there's 2 of them. I'm going to put my first one in, and I found it to be at negative radical 5. And I think you could argue there's a second one at positive radical 5. Oops. If I could get it to graph. So I would say we have 2 vertical asymptotes. And again, you'll notice they're being created when my function is going towards negative infinity or positive infinity, or again here, negative infinity and positive infinity. You see these vertical asymptotes. Now, I want to throw something else at you, and this is a little crazy. I want to talk about a horizontal asymptote. Now, as I'm ballparking it, I'm going to take the verticals out for a minute. And I'm going to try to add in, a horizontal asymptote. And I'm going to say it's at y equals 3. Oh, shucks, I'm on the wrong line. All right. Now look at this, because this is really special. And this doesn't happen a lot in the math you've seen thus far in your math career. So I want you to really focus in on this y equals 3. So it's, I don't know how to change the color, but it's this line right here. Y equals 3 is my asymptote, horizontal asymptote. You can see that this function here is getting closer and closer. But not touching. And you can see this function is getting closer and closer, but not touching that y equals 3. But then what does this part of the function do? Bam! It crashes it. Okay, and that's crazy. We're going to start to see this a little bit this year. A horizontal asymptote, you're allowed to crash. It doesn't happen frequently, but it does happen. So you can crash a horizontal anywhere, but at some point you should see it kind of tailoring off, getting closer and closer on the ends. Now, that is not true for a vertical. You cannot crash a vertical, but you can crash a horizontal. All right, so I'm going to switch back. Oops, hopefully. And keep scrolling here. And I want to focus in more about these vertical asymptotes. So to find a vertical asymptote, the first thing you want to do, so please make sure this is in your notebook, is you want to make sure you have simplified your function, and then you just set the denominator equal to 0. So I've got 2 examples here. This first function, x plus 2 over x minus 5. All right, so it's x plus 2 over x minus 5. And again, I want to show you a graph and see if you can just look at it and find that vertical asymptote. Can you kind of guess where that asymptote's being created, where it shoots off to positive and negative infinity? I'm hoping your gut's saying at x equals 5, and I'm going to go ahead and draw that in. At x equals 5, this looks like it's going towards infinity. This side looks like it's going towards negative infinity, and we're creating that vertical asymptote. Now take a look at that function. Where do you think 5 comes from? Why is that 5 so important? Do you notice it has anything to do with the denominator? All right, so I'm going to switch back to the directions here. To find a vertical asymptote, make sure you have simplified the function and set the denominator equal to 0. So if this is a simplified function and I set x minus 5 equal to 0, I get x equals 5. And that's exactly where we saw that vertical asymptote here was at x equals 5 when that denominator equals 0. So let's go back and look at the second example. Now you'll notice this is not simplified, and I already factored it for you. It is not simplified whatsoever. These x minus 6's divide out. So this function is actually x plus 5 over x plus 3. So you should be able to quickly find the vertical asymptote, hopefully in your head, and we'll verify it with a graph. I'm saying this vertical asymptote is when the denominator equals 0. So I'm going to say that's when x equals negative 3. So let's go ahead and verify with my graph, again on Desmos here. Now you'll notice, and hopefully we were right at x equals negative 3, it looks like there's a vertical asymptote in there. Notice how when I typed this function in, x equals 6 did not pop up as an asymptote. Okay, there is no asymptote here at 6, and that's because I had to simplify that function first. Now you know where they're going to get you on these multiple choice questions. The first choice is going to have both answers in there, x equals 6 and x equals negative 3. And you've got to remind yourself to simplify these functions first. So let's flip back and we'll try a couple examples. So number 1, so our question here is just find vertical asymptotes, and I'm going to abbreviate. You'll see me use VA all year, vertical asymptotes. So before I get excited and set the denominator equal to 0, I have to make sure that it is factored first. So let's see, I'm going to say this is x minus 4 and x plus 3. 4 times 3 makes 12. Signs should be different, and they add to a negative 1 all over x plus 7. So there's nothing to cancel. So in this case, my vertical asymptote is just when that denominator equals 0. So I'm going to say it's at x equals negative 7. Okay. Number 2. Whoops. All right. So again, they're going to try to trick you. We just know that's the case. So we just got to not fall for it. I'm going to clean this up first. I'm going to use the bottom first because that looks simple. 2 terms, GCF. Take an x out, and I'm left with x minus 1. On top, it looks like I can pull an x out, and I've got, oops, so that's x squared plus 4x minus 24. All right, so I've got my x out in front. Factor this trinomial. Let's see, 2 and 12, 6 and 4, 8 and 3. My goodness, I don't think it factors. So I'm going to leave that, and I'm going to say, okay, I can divide out these x's. So it looks like I'm just setting x minus 1 equal to 0, and I'm going to get x equals 1. Now, again, I'm going to tell you that multiple choice is going to put 0 and 1, and 50 to 60% of you guys are going to fall for it. So it's just something we're going to continue working on. And just remember, clean things up first. It will make your life easier. Let's take a look at the third example. All right, a little guess and check on our factoring here. All right, couldn't get nicer though. 7, your only option is 7 and 1. And for 3, our only option is 3 and 1. Now we just have to decide where they go. I think I'm going to go 3 and 1 here. Signs should be different, and I have to add to 4. So let's see, I'm going to make that a positive and a negative. So let's just check. The outside gives me 7, and the inside gives me negative 3, which makes 4, all over 7x minus 3. Now look at this one. This 7x minus 3's are going to cancel. And is there even a denominator? No. So here, there is no vertical asymptote because there is no denominator. All right, this function was just in disguise as x plus 1. And last example here, let's clean this puppy up. Let's see, I'll factor this bad boy. So I'm gonna go 3x and x. All right, 10, we've got 5 and 2 or 10 and 1. Let's play with 5 and 2. I go 5 and 2 here. Shucks, was that a plus sign? That was a plus sign. So the signs need to be the same, and then this minus is telling me they're both negative. All right, let's check. That's a -6 and a -5, which makes -11, so that's great. And the x minus 2, and look again, these are going to cancel. So again, no vertical asymptote because the denominator canceled. So moral of the story today, to check for those vertical asymptotes, we're going to clean up and then set that denominator equal to 0.